I am Alessio Molinari. I will present you the second project of this kaggle delivery. So the first step for the second delivery is feature engineering. It consists basically in manipulating the available features to make new ones so that machine learning algorithms can work better. For each of these newly created variables, we will test its efficiency by looking at the correlation with sale price. First, we notice that in the dataset we have at our disposal many different variables concerning the bathrooms. There are variables for half and full bathrooms, as well as basement and above grade, for a total of 4 bathroom variables. We believe that taken singularly, these 4 might not be so informational, but the total number of bathrooms is surely a significant indicator to our purpose, as it's generally correlated with the size of the house and its quality. This is proved by the high correlation of 0.63 between the newly created feature, dot bathrooms, and the sale price. We'll also add 2 new features: age, a numerical variable defined as the difference between the year of remodeling and the year of sale, and remod, a categorical variable that specifies if the house has been remodeled or not. Here, for example, we can see the sale price is higher if the house has not been remodeled than if it has been remodeled. When we buy a house, we are also aware that some neighborhoods are better than the others, and the more sought after a zone is, the more costly a house on the land is. That's why we decided to be neighborhoods and sort them according to the average price. Once we have done this, we can see from the graph that there are clearly 3 wealthier and 3 poorer neighborhoods, while all the other ones are not too different from one another. Since we don't want to overbid, we decided to split houses in only 3 classes of neighborhoods: rich, poor, and average, categorized in 0, 1, and 2. Another very simple yet interesting predictor that we can add is the total living area, calculated as the sum of basement area and above graded living area. Finally, we aggregate all porch variables following the same logic that we use for the bathroom variables. Together they are more informational than the single ones. Namely, we added together 4 different porch variables, but this time the correlation with the response variables is not so relevant, being only 0.90.
Okay, this is Jinrui Liu, and in this part I will introduce the model we used, lasso regression. First, to make a prediction, it's normal to think about using a regression method. The most common one is linear regression. Linear regression is a regression analysis technique, and its variable is continuous variable, and the linear regression is a supervised learning. In our case, we also compared with range regression and lasso regression. Let's take a look at linear regression first. Here is the assumption functions and loss functions. Our goal is to minimize the loss functions. The problem in linear regression is the overfitting, and we have 3 solutions to solve the overfitting problem in linear regression. One is feature reduction. We can use PCA to choose the main component. Another way is to add normalization parts here and here. Range regression and lasso regression are based on the second way. The main difference is that lasso use L1 norm and range regression use L2 norm. It is known that range loss shrinks the coefficients of correlated predictors towards to each other, while the lasso loss tends to pick one of them and discard the others. We can also see in the picture, range will tend to 0, but still smooth. Lasso was almost flat, because smiling theta in lasso loss are equal to 0 at that time. I have also tried range regression, but since lasso gives the best results of those 3 models, I'm only keeping the lasso model in this project. parameter lambda controls the overall strength of the penalty. The first thing I did is using caret cross validation to find the best value for lambda, which is the only hyperparameter that needs to be tuned for the Nassau model. After finding the best lambda, we applied the lasso regression to our dataset. The result shows that lasso did what it's supposed to do. It did the job well by not using about 45% of the available variables in the model.
My name is Ignacio Garcia, and let's continue with XGBoost model. XGBoost model. Gradient boosting comprises an assemble method that sequentially adds predictors and corrects previous models. However, instead of assigning different weights to the classifiers after every iteration, this method feeds the new model to new residuals of the previous prediction and then minimizes the loss when adding the latest prediction. So, in the end, you are updating your model using gradient descent and hence the name gradient boosting. This is supported for both regression and classification problems. XGBoost specifically implements this algorithm for decision tree boosting with an additional custom regularization term in the objective function. In R, we work directly with XGBoost package, providing us with a cross-validation function and determining the optimal number of rounds. The main parameters to tune to avoid overfitting are max depth and mean child width. And we set a grid that tunes both these parameters and also the learning rate, as we can see in this part of the code. So we find the best hyperparameters using caret function from XGBoost package. And it says that the best tune parameters are max depth and mean child width. So we continue working with the preparation of the data in the recommended format and taking over the best tuned values from the caret cross validation. After this, we have to continue with the process. We have to determine the best number of rounds. After computing various number of times, we discovered the number of rounds are 454. With all the previous work, we can use the prediction using XGBoost and plot the results. So we can say that the most important feature is the total square feet and then the overall quality of the house. So we can see in the graph, we can explain how much important are these features comparing to the final price of the house.